We're going to be writing equations today, and we're going to be doing a couple of other things. And so first of all, it says write an equation for the ellipse with foci 19,3 and -7,3, and length of the major axis equals 30. So we left off with this yesterday. Okay, biggest thing you need to remember here is draw a quick sketch. Okay, so I'm going to go ahead and draw a quick sketch for the 19,3 and the -7,3. Okay, so very first I've got 19,3, which is right here. And then I've got -7,3. Remember, it doesn't have to be perfect. So what's the very first thing I do? Find the center. Yep.
Should I go up? Yeah.
Oh, okay. Oh, yep, you're right. Okay, so really what this should be, let's change that. Okay, so here we go. There, that better? Okay, so 19,3 and -7,3. So what I need to do now is I need to go ahead and find the center. So the center is going to be where? Yep, in the middle of those two, which is where? Yep, at 6,3. So very first thing what we need to write down, the center is at 6,3. Now what I need to do is I need to go ahead and find, okay, what is this distance going to be? 13. And so that tells me that C equals 13. Okay, the reason why it's C is because what? It's the foci, okay? And so then what else do they give me in the problem? They give me the length of the major axis equals 30. So the length of the major axis equals 30 tells me that A equals 15. Because from end to end on the major axis is 30, so half of that would be A. So A is 15. So if you remember our formula from yesterday, I have a quantity here squared, and I have an x in here. And then I have another quantity here squared, which is y squared, and then that's going to equal 1. In that formula, I know that what goes in the parentheses first with x? -6. What goes in with the y? -3. Okay, now I need to find what? Yep, 15 squared, and where's that going to go? Under the x. So that's going to be 225. What's going to go under y? You have to find it. Okay, we know that c squared equals a squared minus b squared. Okay, so c squared is going to be 169. A squared is going to be 225. So what does b squared equal? $56. Now you don't need to go down and find what b is, because in the formula is b squared. So I could stop right there, put 56, and then I'm done. Okay? Alrighty. So let's see what I have next. Okay? All right, write an equation for the ellipse with major axis from -6, 2 to -6, -8, and minor axis from -3, -3 to -9, -3. So if I were writing this down, I would just put major axis -6, 2, -6, -8, minor axis -3, -3, -9, -3. That's what I would do. Okay, then that way you don't have to write out a bunch of extra stuff. First thing I'm going to do is go ahead and plot my major axis. Okay, so the major axis, okay, is going to be at -6, 2 and -6, 8. I also know that the minor axis is at -3, -3, and -9, -3. Okay, so -3, -3, and -9, -3.
It's -6, -8.
Oh, did I? Wait.
Negative.
I wrote it wrong. There's a negative there. Okay. So now what I need to do to find my equation is I need to find what? What? The center. Okay, so where's the center going to be? Yep, so I know -6, -3. Okay. What is this distance going to be? 5, and what does that equal? A. So I know A equals 5. Okay, next. What does this equal? B, and what is that? 3. So now let's go ahead and use our formula. Okay, our formula is going to be a quantity x squared over something, y quantity squared over something, and that's going to equal 1. A goes underneath of what? The y, because it is vertical in orientation. So underneath y, I'm going to have 25. Reason why it's 25 is because remember it's a squared. What goes underneath x? 9. That's 3 squared. What goes in the parentheses for x? X plus 6 and y plus 3. There you go. And there's your equation. Okay. Next thing we're going to talk about is what's known as eccentricity, and this is what's going to end. Okay, the key concept below is how it's written in your book. Really, all you need to know are these 3 things that I have up here. The eccentricity of an ellipse is a ratio of C to A. It's the ratio of C to A. It is always between 0 and 1. It determines how circular or stretched the ellipse will be. So depending on the results for your eccentricity, you can see if it's going to be more circular or more elliptical. Okay, I'll let you get that down, and then we'll go ahead and look at how you find the eccentricity. So we're going to go ahead and look at an example now, and we're going to find the eccentricity. Okay. So, determine the eccentricity of the ellipse given by. So all we need to do here is identify what we're given in the problem. And we're given x minus 6 quantity squared over 100 plus y plus 1 quantity squared over 9, and that's going to equal 1. So in this problem, this is A, obviously. What does A equal? 10. Okay. What does B equal? 3. So remember, the eccentricity is C over A. So what I need to do is I need to find C. So to find C, I'm going to use the formula. C squared equals A squared minus B squared. Okay. So in this problem, I know that A squared is 100 and B squared is 9. So what does C squared equal? 91. So C equals square root 91. So now to find the eccentricity, I'm just going to take C over A, which in this case is root 91, over 10. Now, if you wanted to answer that as a decimal, you could. When you take the square root of 91, you're going to get like 0.954, or 9.54. When you divide it by 10, you should get your answer to be 0.954. Okay? Questions?
Can you leave it in the other?
Doesn't matter. Any questions? All right, let's look at this one. Determine the eccentricity. X minus 4 quantity squared over 64 plus y minus 3 quantity squared over 36. That's going to equal 1. So first thing what I'm going to do is I'm going to identify what I'm given in the problem. I'm given that A equals 8. I'm given that B equals 6. So once again, I need to find what C is. I know the formula C squared equals 64 minus 36. What is 64 minus 36? 28. So what does C equal? We're at 28, but you need to reduce that down. So to reduce that down, you know it's 4 and 7, 2 and 2. So C really is 2 root 7. So your eccentricity, once again, is C over A. So in this case, it'll be 2 root 7 over 8, which is really root 7 over 4. Questions? So far we've learned how to graph ellipses, how to write equations of ellipses, how to find the eccentricity of ellipses. And the last thing we're going to end with is the standard form for the equation of a circle, because a circle is a special ellipse. All you need to get down, if you're writing this, I would put circle, write the word circle, and then write this formula. Once you get that formula down, we're going to talk a little bit about how, if it's not in this form, how you can recognize it's a circle. Okay, what can you tell me about a circle? It's round, okay, a little bit more, let's go. What?
360 degrees.
Okay, it's 360 degrees, what else? You were saying something back there. The radius. Okay, the radius is how far it is from the center to the outside of the circle, right? So if I were to say major axis, minor axis, what could you tell me about that with respect to a circle? They're equal. So you're not going to have a major axis and a minor axis. And in fact, if you had an ellipse in this form, this is going to be a circle. Okay, so when the two denominators are identical, it's a circle. And in this case, you're probably wondering, well, how could you figure out the radius? Well, how you can figure out the radius is that in order to solve that, you're going to multiply by 4. Okay, now when you multiply by 4, those cancel, and then you're left with x minus h quantity squared plus y minus k quantity squared equals 4. So that would actually be a circle with radius 2. Okay. So that's one of those things, keep it in mind. All right, your assignment, once again, you've already given this earlier. All right, you need to get it done. I would probably expect a quiz over ellipses tomorrow.